guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So now we move on to Biomolecules Survey Part 3 that involves amino acids, peptides, and proteins. So protein structure is extremely important because molecular structure controls function. So just like we talked about in stereochemistry, understanding the structure leads us to understand all the different applications and importance of the different biomolecules. So for example, by looking at the protein structure, we can look at enzyme selectivity, drug design, as well as many other applications. So let's start out by talking about amino acids. And amino acids are the fundamental building blocks of peptides and proteins, where peptides are made up of short sequences of amino acids and proteins are much larger molecules that are still made up of these fundamental parts. And so all amino acids have carboxylic acid groups as well as amine groups, where this part right here is the amine, this part right here is the carboxylic acid group. And you guys should know all of this now because you guys are familiar with functional groups. And right here we have the R group, which is the side chains. So we're going to go over 20 essential amino acids that you will have to memorize for this course. And for each one, they all have this amine group and this carboxylic acid group, and they all differ in their R group. And so basically, an amine plus a carboxylic acid allows for proton transfer to be possible, right? And so I'm showing this in this diagram right here, where an ion at low pH would have a positive charge on the NH3, and then at a neutral pH, you would have a deuterionic form, meaning that you have both positive and negative charges, and finally an ion at a high pH value would have a negative charge on the carboxylic acid group. The reason for this is because of the different pKa values. I'm sure you went over this in general chemistry, but let me show you why we have different charges at different pH values very quickly. So let's say we have a table of pH, and then we have COOH, the carboxylic acid group, and we have the amine group, NH2. And I'll put charge right here. And so the approximate pKa of COOH for the C terminus is 3.8. And for the N terminus, NH2, it's approximately 7.8. So now let's try a low pH value, such as pH 1. At a pH of 1, the pKa of COOH is 3.8, so it's going to be protonated, right? Because the pKa is higher than the pH value, so this would be protonated. COOH in its protonated form is just COOH, and thus it's going to be a charge of 0. For the NH2, on the other hand, the pKa is 7.8. Since this is higher than 1, it's protonated, and thus it's going to be NH3+. And thus we have a charge of +1. And if we look at the ion at low pH, the overall molecule has a charge of +1. Now let's try a neutral pH. So at a neutral pH, this pH value is now higher than the pKa of COOH, so thus this is going to be deprotonated. So carboxylic acid in its deprotonated form is COO-, so thus we have a -1 charge. For the amine group, it's still going to be protonated. Since a pH of 7 is still lower than its pKa value, and thus it's going to stay as NH3+. So at this point, we actually have an overall charge of 0. So this zwitterion has both a positive and a negative charge that ends up canceling out. Finally, we can try a high pH value, let's say a pH of 10. And in this case, the COOH would still be deprotonated as COO-, so a charge of -1. The NH2 would now also be deprotonated because the pH value is higher than the pKa value. So now this would be NH2 with a charge of 0, and thus the overall charge on this molecule is -1. So we can tell what the ion or the particular amino acid is going to look like depending on the physiological pH value. And it can go back and forth from having a positive charge to being neutral overall to having a negative charge.